problem of the day for 30th January. So yeah, here is the problem: divide node into maximum number of groups. So I have tried this problem and solved this. So I am gonna share you with the solution. So the problem is, we are given an undirected graph, right? And what we have to do, so you are given a positive integer representing number of nodes in the indirect graph. Node are labeled from 1 to n, right? So it is n, means n number of nodes, and all nodes are labeled from 1 to n. And we have given an array edges. So edges means the connection between two nodes. Now we have to divide a graph into m groups such that each node in the graph belongs to exact one group. Okay, so that means, like, in this continuous graph, this node should always begins to only one group, and for every pair of node in the graph that are connected by the edge, if A belongs to a group with index x and y, and B belongs to group with index y, then y minus x is equals to 1. So that means the difference between the difference of the group between two connecting node should always be 1, right? And if it is not possible, then we have to return -1. So this is the question. I hope you understand the question well. So let me explain you again. We have given a graph. So graph is like, there are n nodes starting from 1 to n. So there are 6 nodes, and we have given the edges. Edges represent the connection between the nodes. Now we have to divide the graph into m possible groups, such that the one node belongs to always one group, and the connecting nodes, right? Connecting nodes should always be in the consecutive groups, right? So what I mean to say is, so 3 is connected to 2 and 6 is connected with 2, right? So that means 3 and 6 should be in the one group. So this is one possible case. There may be a case in which 5 is connected to 1, 2 is connected to 1, and 4 is connected to 1. So 2 and 4 is connected, belongs to one group, and 5 is belongs to other group, but these are consecutive groups. So 5 and group of 5, that is one group 1, and group of 1, that is group 2, are consecutives, and group of 1 and group of 2 and 4 are consecutive. So that is the problem. This is a hard type of problem, so we have to think a lot about it, right? So the one observation is, let's say we have let's me open the paint, right? Okay, so let's say we have a node 1, node 2, and node 3, right? This is the case. So in this particular case, let's say we make this a group, then we have to make this a group, right? Or we can say this is a group, but these two also belongs to similar. So one is connected with 3 and one is connected with 2, right? So this is not possible. Because we cannot make this group, right? Because they both are connected. So we cannot, because we cannot combine them in a single group, right? And we cannot make this single, because if we call it 1, if we call it 2, if we call it 3, right? So difference in these group becomes 3, which is greater than 1, right? So this case is just not possible. So first observation is, if it is a cycle, right? So one, or let's say take a second example, 3, 4 and 5, right? these are connecting like this, and let's say we make one group. We cannot make it like 1 and 2 in a single group because these two are connected, so the difference between the group will be 1. So if it is a group 1, then let's say 3 and 4, 2 are in the second group, so let's say 2. But still it is not possible to make different groups, because if we make it 3, then we have to make it 4, and then difference between 2 and 4 will become 2. So that is not possible. If we cannot make it like this, we cannot make it like this either, because if it is 1, if it is 2, then it will become 3, and difference between these two groups will be 2. So that is not also possible. So one observation is graphs by type means simply we can say any node at a level should not be connected to other node at the same level, right? So this is the final observation. This is the first observation, and then what we need to do is we need to return the maximum number of groups, right, possible. So it is nothing but the maximum difference between any two nodes, right? It is nothing but maximum difference between any two nodes. So let's say we have a root node at 5, so we can say that till here we have 4 levels. If we have a root node at 2, right, so we can say we have one level, this second level, so we have 3 levels only. So we have to maximize this distance, right? So how to solve this? So for this what we need to do is we need to use union find along with the BFS. Union find for finding the different number of graphs. So there may be cases where this graph is not connected, so the whole graph is not connected. There will be cases where there are 2 or 3 graphs. So for finding a root node in any graph, right, we are using union find method. So union find is nothing but to use to solve the disjoint sets, right? So here we represent a disjoint set with a particular, let's say, okay, so we have a representative of a disjoint set, so we can find it using find method. And if we want to merge two disjoint sets, so we can use union method. We have solved the previous yesterday's problem of the day using union find method, so you can go through that problem to learn more about this, right? So we have write down the union find method. So if it is nothing but we have created a union find, which is nothing but the representative of any node inside a disjoint set, right? So let's say there are 2 graphs. So let's say there are 2 graphs, 1, 2, 3, 4 and 5, 6, 7, and we represent this graph using this node and this graph using this node, right? So you have union find of every node is 1 and union find of these node is 6. So this is the representation of nodes inside a disjoint set. Disjoint set means the exclusive sets, right? Which is not, there is not any union between these two sets, and if we want to merge those sets, right? So let's say there is a connection here, so then we will update either its representation or either their representation. So if we are updating their representation, so we will update 2's representation to 6, or we can say we can update 1's representation to 6, and then we will update all the representation to 6. So this is all we do. Union find of find x. Find x means the representation of x is equals to representation of y. So here the representation of x is nothing but 1 will be represented by this 6 now, because it is now connected. It is not a disjoint now. And if so x is not a union find x, x is equals to union find x means, so 1 will be represented by 1, then it means it's a root node. 2 will be represented by 1, 3 will be represented by 1, so these are not the root node, but if 1 is represented by 1, so that is means it's a root node. So this is how we are finding union. So union find or root node of this graph. Now we are using breadth first search to finding the nodes, right? So what we are doing is we are also making a scene or a visited dictionary, and we are appending all the nodes inside it. And if we saw that any dictionary, any node which is present at a same level, and we have visited it earlier, right, and we can visit it again, so that means 2 nodes are connected at the same level. So that is not possible. So if seen neighbor is equals to label, if seen neighbor is equals to label, so we will return -1. So that is not a possible case. So what we are doing, we are visiting the graph at any node from considering any node at a root as a root, and we are using BFS. And what we are doing, we are making a graph using this edges, and this is maximum group. Maximum group is nothing but the maximum number of labels which can be possible, or maximum number of groups which can be possible inside a disjoint graph. So there may be some cases where there will be present 2 graphs, right? So either this node, not this node, this edge will not this edge is not present, so there will be 2 graphs, one this graph and one this graph. So for every I, right, in the range 1 to 9 for so we are processing from every node, and we are finding the maximum number of group possible from that node. And if it is, so this is the group, right, and root is nothing but the representation of one graph. So if there are 2 graphs, right, so this whole graph will be represented by one root, and this graph will be represented by one root. So what we will do, we will find the maximum number of groups possible from this graph, and we will note it by the maximum group of root of that graph, right? So this is the case, and we will return the sum of the maximum values. And this is how we are solving this problem, and this is solved with 100% beat. So I hope you understand this solution. I suggest to go through this video one more time, read about this union find method, BFS, if you are not aware about BFS, and this is then just another algorithm to solve this hard problem. I hope you learn something from this video. Thank you for your time. Thank you.